Okay, so today we will be looking at both numerical long division and algebraic long division. We're going to start off today by looking at numerical long division to set up the theme, which will help us later for algebraic long division. We're going to look at a couple examples of each, and the first example we're looking at for numerical long division is 806 divided by 62. So we're going to think about this question slightly differently, okay? Again, we're going to set this up differently, as well as you can read there. We're going to think about repeated subtractions, okay? How many 62s can I remove from 806, okay? And the amount that I can remove is my final answer, okay? That's how many it will tell me it can go in by. So that's our sort of thinking behind this. So if we set it up initially to start with, now you won't have 13 to start with up here, that will be my final answer that you'll put in at the end, okay? But we're going to start off by doing 62 divided by 806 in a slightly more traditional fashion. However, what we're going to do is we're not going to try and substitute all these into here in one go, we're going to do subtractions, okay? So I need to try and think about how many 62s I can remove from this value first, okay? It'd be good if we can get rid of quite a lot to get my number smaller. Now I know 10 lots of 62 would give me 620, okay? So I'm going to remove that from 806. I'm going to remove 10 lots of 62, which would be 620. And it's always a good idea to write down how much you are removing here. If I do this subtraction now to work out how much I have left in my question, I have 186 left, okay? So again, you can see I have made my number a lot smaller by taking 10 lots of 62 away from 806. Okay, I now need to try and work out how many 62s I can remove from here. Okay, initially, you might find it beneficial to just take off one lot of 62 at a time. So if I remove one lot of 62 off, okay, I'm going to get the answer 124 left. Okay, so I've took one lot of 62 off from 186 and I've got 124. So far I've actually took 11 lots of 62 off. I am now going to see if I can take any more. Well, I can, because this number is bigger than 62, so I can take another 62 off. I'm left with, okay, 62. If I do that subtraction, I'm actually left with 62, which will be nice because it means I'll be able to remove it all completely. So I can take another 62 off to finish it off, and I have 0 left. Okay, now that 0 left is important. You won't always get 0 there. That 0 means I had nothing left. I managed to get rid of all 806. Okay, so therefore my answer to 806 divided by 62 is 13, because I managed to take off, if I add all these up, 13 lots of 62 off. These were the total amounts of 62 I could remove. Okay, so I didn't have any remainders left, there was everything gone, so my answer was 13. Okay, we'll look at a second example to try and clarify this. So we're going to think of just slightly bigger numbers now. Okay, 9,245 divided by 43. Again, we're going to think about how many lots of 43 can I remove. Okay, and hopefully we're going to try and get a bit more practice at removing bigger chunks of this. Okay, because if I can remove bigger chunks, I get my answer quicker. So we're going to set this up again. Now, if you can check with a calculator, you're going to get the answer 215. If you do 9,245 divided by 43, you do get 215. So let's see how we get this. Well, I want to try and remove as many 43s as I can. You might spot that if I times this number by 100, so 100 lots of this, that would be 4,300, which I can remove. So I'm going to remove 100 lots of 43 straight away. If I do so, okay, what I am left with? I am left with 4,945 if I do that subtraction. Okay, I'm going to be left with that here. I can now take another 100 off. I've got enough left to take another 100 off. So I can subtract another 4,300, 100 lots of 43. And I am now left with the value that I obtained from the subtraction of 645. So I've managed to get my number a lot smaller quicker, okay, by taking big chunks off. So far, I've actually removed 200 amounts of 43 from my question. Okay, that's what that means there. So I can't take off 100 anymore, okay, 100 lots of it, because that would be too much, but I can try and take off something else a bit bigger as well, okay. I can now take off 10 lots, okay, because 10 lots of 43 would be 430, so let's remove that there. Okay, so if I remove that from 645, I have now removed 430 amount of it. I am left with 215. So taking 10 lots of 43 off this value here, which was taken off 430, would give me 215. I am now thinking about, okay, how many 43s can I remove from this? I can still keep going, this number's bigger than 43. You might spot that 215 is exactly half of 430, which was 10 lots. So I can remove 5 lots from this, okay? 5 lots of 43 is 215. And again, I can now remove everything and I get the answer 0, okay? So remembering, there's nothing left to subtract now. I don't have any remainders left, I got rid of it all. So if we add up the whole right hand side, okay, so I'm going to add up all my values that I managed to write down here. So I've got 100 plus another 100, that's 200, plus 10, that's 210, plus 5. Therefore, my answer that you would then write at the top here is 215. And we get the answer 215 there. So that is how we would do it for numerical long division, okay, just plainly numerical values. We're now going to look at how we're going to do this for algebraic fractions, okay, and it works in a very similar process. So we're going to start off by looking at this first question here. I've got x squared plus x minus 5, and we're going to divide that by x plus 3, okay, that's what I'm going to hopefully do. So the aim is here, again, we want to try and cancel this down. Now you'll see here, now this is only part of my answer this time, okay, you'll see why at the end, but I'm going to manage to get an x minus 2 at the top. I'm going to show you how. What we want to do is we want to, again, if you think about back to the numerical ones, okay, we managed to get this big number in here down to 0, or down to something smaller than what was here, okay, and that's the plan again this time. We want to try and get this down to size to something that is smaller in value than that here. When we talk about values, we talk about the size of the degree of the polynomial, okay, so here, this is actually x squared. The biggest terms here is x squared. This is just an x term, okay, x to the power 1. So therefore this is deemed smaller than this. So what we want to do is try and cancel, and we cancel it by one term at a time. So we want to try and get rid of the x squared, okay, that's what's biggest, okay. So how we want to do this, we want to think about what we can multiply this by and then subtract off to get rid of my x squared. Well, my biggest term here is x, and I need to get it to be an x squared to cancel. So I'm going to multiply both of these things here by an x. Okay, so I'm multiplying it by an x there, that goes there. And if I multiply both of these by x, I'm going to get x squared plus 3x. So I'm going to subtract x squared plus 3x off of this. It's always a good idea to have your x squares and your x's and your numerical values all in a line so that you keep it neat. Okay. This will cancel the x squareds if I subtract them, which is good, that's what we wanted. I now need to work out what would I have left. So if I do x minus 3x, that gives me negative 2x. And I'm going to be left with negative 5 subtract. Well, I didn't have anything in this column, so I'm just going to be left with negative 5. So if I multiply this by x, I get that value there. Subtract it off what my question was to start with, I'm now left with here. So I've managed to get rid of the x squared, which was the biggest term. Okay, the biggest term now is x. And now I want to get rid of it by using this value here. Okay, so I want to try and get the same thing in front of the x, which is negative 2. I'm going to multiply this here by negative 2. Okay, if I multiply this by negative 2, I get negative 2 times x is negative 2x. Negative 2 times positive 3 is negative 6. Okay, and I've just noted down that I multiplied by negative 2 here. Okay, and you can actually see now why at the top I've got an x and a minus 2. I've got an x there for that x there, and minus 2 there for that negative 2 there. So again, if I'm just careful when I subtract this, okay, well the good thing is these are the same, so if I subtract them they'll disappear, which is cancelled out. Negative 5 take away negative 6, okay, just be careful with your negatives here, but negative 5 take away negative 6 is positive 1. So I actually have 1 left over. However, I cannot cancel this out now, okay? My biggest term here was x, okay? And I cannot multiply this by something to end up with no x's there, okay? So that's why 1 is now my remainder, okay? I can't get rid of it, that's what was left. Now that is key because that 1 is still in part of our question. That is an important part we need to remember. My final answer, that is going to be my answer to start with. It's going to be x minus 2, but I need to deal with this 1. And remembering, this is 1 out of x plus 3. Okay, so what my final answer looks like, okay, we started off with this question here. My answer was x minus 2, that's what was on the right hand side, plus my remainder 1 over x plus 3. Okay, remember we couldn't quite get rid of that, so it's still 1 out of x plus 3. And that's my final answer for that question there. We'll look at one more example to try and make sense. Right, example 2. Okay, and again, you don't panic. You'll see here that this is a bigger question. The powers have increased. Okay, however, the setup will remain the same. Okay, so my job here is to try and get rid of this term at the top using this term at the bottom here. Okay, so again, I'm going to set it up like this. Now, my final answer, or the whole part that I can subtract out of this, will be x minus 2 again. I'm going to show you how that works. You'll write that down at the end, you don't write that down at the start. So, I need to try and work out how to get rid of this x cubed. Okay, the biggest term here is x squared, so if I multiplied everything here by an x, I'm going to get an x cubed, and then I can subtract them off, which is good. Okay, so I'm going to multiply everything along here by x. If I do that, I get x cubed minus 4x squared plus 5x. Okay, I am now going to do a subtraction from this term down to this term, and again you can see why it's beneficial having your terms aligned. They cancel, okay, if I subtract them. Negative 6 take away negative 4 lots of x squared, well, that gives me negative 2 lots of x squared. Okay, 16 minus 5 lots of x is plus 11 lots of x, and I've still got my negative 11 there. Okay, so that is my answer that I had left after I took this out of that polynomial there. Okay, so I can now try and work out how I'm going to get rid of the x squared. The good thing is all the x cubes have gone. Well, I can still try and get rid of the x squareds here because I've got x squareds there and I've got x squareds there. I now need to multiply this by negative 2, so I've got the same thing as here, which will also be negative 2x squared. If I multiply this by negative 2, I get negative 2x squared. Okay, if I multiply this by negative 2, I get positive 8x. If I multiply this by negative 2, I get negative 10. Remembering we're now doing a subtraction in order to try and get rid of this now. So I am getting rid of these are the same, so they will cancel. 11x minus 8x, so that will give me 3x. Negative 11 minus negative 10, that will give me negative 1. Okay, so again here, I get my answer 3x minus 1. I cannot cancel this any further, okay? The biggest term this has now is just x. This I could only manage to get rid of by multiplying, and it would leave me with x squareds, okay? So I don't want to do that. That is how much I can take away. So that is now my remainder. So again, my answer was x minus 2 at the top of my sum there, okay? Because I had to multiply by an x, then I had to multiply by a negative 2. So my final answer looks like x minus 2, the bits on the right hand side, plus my remainder, which was 3x minus 1, out of what I was dividing it by, which was x squared minus 4x plus 5. Okay, so there's two examples of long division that you can try. Thank you.